Hello everyone, this is Niveta Lakshmanan. I am working as a software engineer at CAT Software. And I am also an Microsoft certified trainer. So today we are going to talk about Azure Durable Functions. So um, so today's agenda is we'll see what is Azure Functions, and then why do we need to go for Azure Durable Functions, what it is, and we'll see some of the patterns and the function types. Okay. So before we get into it, what is an Azure function? So we know like Azure function is some kind of a normal function that we write in a C sharp. The same way we write a small piece of code and we'll put that or publish that into a cloud. So that is what an Azure function is. In a simplified way, it is like we are just writing a small piece of code and putting that into a cloud and making that function available for all of them. We can access it at the same time. Okay, so we are publishing it to the cloud, right? So we have to have some kind of infrastructure issues, right? When we do it in our local machine, we need to set up our Visual Studio and we need to write the code. If you want any third party services, you need to install them. So those things we don't need to worry in cloud. So that is what we say, that we don't have to worry about the infrastructure in cloud. The second thing is the function is triggered by a specific type of event. So specific type of event means, for example, if you wanted the function to get executed, what we'll do is like we have so many kinds of triggers. Okay, so for example, if you take HTTP trigger, Q trigger, blob trigger, we have so many things. Okay, so what this will do is like, for example, we have an HTTP trigger endpoint. Okay, for example, HTTP and some kind of 7701 and the function name. If you see the HTTP endpoint, when you give it in the browser, it automatically triggers the function that is linked with the HTTP trigger. So as soon as the HTTP endpoint is clicked, it will call the function and then the function will get executed and gives the result back. So this is what Azure Functions actually does. Okay, we have timer trigger and so many other triggers. Okay, the next thing is scalable. So if you wanted to know what is scalable, scalable is nothing but, for example, in a festive season, you'll have so many requests to your system, to your functions, right? To your application, there will be so many requests coming in. For example, you have a retail application, you are selling some kind of clothes in your application. What will it happen is like, during the festive season there will be so many demands to your application. So at that time, if you wanted the application to scale in or up, what this will do is like, this Azure function itself will take care of the scaling up process. And when there is no demand, for example, in if there is no festive season, there will be not having so many requests to the application, right? So that will be their your request to the application will be very less. So at that time, the application needs to be like scaled down, right? We don't have to have so many resources handling it, right? There will not be so many requests, so we'll scale down automatically. So this is what it is, scalable. Okay, next is pay per use pricing model. Pay per use pricing model is like, uh, um, for example, your Azure function is running on every morning at 9 o'clock and it runs till 9:05. Okay, so for 5 minutes in every day it will get run. Okay, so for this pricing model is like, you will pay only for that 5 minutes that is running the code. Okay, we don't have to pay for the whole day. Okay, we are just paying the money only the for the code that we run. Okay, next is it supports multiple languages. So multiple languages is means, we have C sharp, F sharp, Python, JavaScript, and so many languages. So Azure Functions support most of the languages, and we say that Azure Functions are stateless functions. Why? Because it's like we don't have any way to maintain the state. For example, when you give an HTTP normal, if you browse it in a browser, normal browser, if you go and give www.google.com, we know that HTTPs are stateless, because whenever we give the request, it gives the result back. We don't have any state maintaining or tracking mechanism inside that, right? The same way the Azure functions have no tracking mechanisms or no state maintaining properties. Okay, so if you wanted to add a state maintaining property, you can add it through the code only. Okay, we can't do it by itself. The Azure function will not do by itself. It is a stateless function. So that's all. So this is what an Azure function is. So we have Azure function that is doing all the things. Then why do we need to go for durable functions? So that is the question that we will get it, right? So we'll see why Azure functions cannot maintain in a picturized format, so that you people can understand even more better than what I tell it in theory. Okay, so for example, let us assume that it is a client. Okay, the client is now giving a request. For example, this request is an HTTP request. HTTP that we'll give, right? 7071 slash, we are calling the function. Along with the function, we are calling the trigger. Okay, so we are sending the HTTP endpoint as a request, so that as soon as we give the endpoint, it will trigger the function, right? So HTTP trigger is initiated, and it goes and fetches the corresponding HTTP function, and then this function will get loaded into a container. Container is nothing but a place where the function executes. Okay, so as soon as it gets loaded into a container, this will get executed and gives the response back to the client. Okay, here, and so as soon as it gives the response back to the client, this container will get died. So next time if you give the same HTTP endpoint, it will trigger fetch the function and load it in some other container and gives the result. So this is why, as we say, the container dies after each and every response is given. We will not have any will not have any kind of maintaining mechanism, right? We cannot maintain any state here. So we request, it gets triggered, the function will get executed into a container and then gives the result back to the client. So here, as soon as it gives back the result, the container dies. So we are not maintaining any state in this particular Azure functions. So in order to maintain state, we have durable functions. So durable functions is used for, it is mainly used for maintaining state, and you can even use these durable functions for a long running process. For example, in Azure functions, the maximum time that it gets run is like around 10 minutes. Okay, so for example, if you run a function that takes more than 10 minutes, it gets the timeout issue. So but in durable function, it is like you can run a long running orchestrations, long running functions that will gets executed in durable functions. So two main things that we go for durable functions, it's like, one is it maintains state, and the second thing is, if you wanted to run a long running functions, then you can go for durable functions. So here I am saying that another one point is like supports orchestration over choreography. The first image that is over here is orchestration. The second one is the choreography. So orchestrator is in this durable functions, we have three function types. We'll see it in the later slides. But before that, I just wanted you to know, like, why do we need to go for durable functions? Right? I'll just explain like how the durable function gets work. Okay. So this is an just assume that it is a function. This is an orchestrator function, and these are all these service A, service B, and C are the activity functions. So what this orchestrator function does is, this is the one that actually coordinates all the activity functions. For example, let us assume that service A is an add add function. This is an sub sorry Service B is the subtract function. Service C is the multiplication function. So what we are going to do is like we are just going to pass two arguments to the service A function, that is an add function. We give the request, and until it get back the result, this orchestrator function will be in an idle state. Okay, it will just be in a sleep state. It doesn't do anything. Okay, so this orchestrator function will be in an idle state. It gives the request to the service A and waits till the response is back. Okay. So once the service A function is done, then it gives the result back to the orchestrator function. So this function will maintain the state of the service A. Next, the orchestrator will then, as soon as it gets the result, it saves it in the history table, in your storage account, and then this orchestrator function will send the request to the service B. So this will be in a pattern. Okay, there are so many patterns, as I said before, there are so many patterns available, but this orchestrator function is the one that is going to coordinate all the activity functions. It unless and for example, if the orchestrator function calls the activity function, it waits till the result is given back from the activity function. Until then, the orchestrator function will be in an idle state. Okay, so because of this orchestration, durable functions could able to maintain the state. Okay, so these states are maintained in your table storage. When you create a durable functions, you'll have a storage account associated with it. In that storage account, you will be having a table. In that table, each and every request and response are being recorded, and with that history table only, this orchestration is we could able to maintain the state. So far, I think I am clear. If you have any doubts, you can put it in the comment section so that I can be even more clear if you have any doubts. Next is what is durable function. So we have seen, right? We have seen what is Azure functions, how it works, and everything. Why it doesn't maintain state, and we saw why do we need to go for durable function. Then it is what? Okay. What is durable functions? So durable functions is nothing but the extension of Azure functions. It actually helps in maintaining the state. Okay, we are going to maintain state in durable functions. That is why we are going in. And the if you wanted to maintain a workflow, we'll use the orchestrator functions. So the extension defines stateful workflows by writing orchestrator function, and stateful entities by writing entity functions. So as I said, there are so many function types available. If you wanted to have a stateful workflows, then you need to go for orchestrator functions. If you wanted to maintain stateful entities, then you need to write an entity function. So in this demo, we'll see about the workflow and the orchestrator functions with the help of orchestrator functions. Entities is nothing but the for example, let us take, we have a variable called count. So for each and every trigger, the count needs to be incremented like 1, 2, 3. So in order to update a particular variable, then we'll go for an entity functions. In this, we are just going to make a workflow, and with the help of the orchestrator functions and the activity functions. So that's all. So we have seen the theory part, like we'll see how the code looks like. So this durable functions look like, the code will be like this. Initially, you'll have a client function. As I said, there are so many function types, so I'll explain it in the later videos. Just get the word alone. There will be a client function. That function will call this orchestrator function. If you see a durable orchestration context inside your argument, then this is the orchestrator function, and this orchestrator function will have the code for calling the activity function. The method that needs to be called is call activity async method. Okay. So this is the durable functions, durable orchestrator function, and these are all the activity functions. For example, this activity function is like in a sequential manner. F1, F2, and F3 are the function names. Null, x and y are the inputs that we are passing it. Null is sent as an input to F1, X is sent as an input to F2, Y is sent as an input to F3. So these X and Y variables are like we are calling the function one method getting the result in X, and we are passing this X as an input to the next activity function. It is like we are running this function in a sequential manner where we are getting the function, getting the output of one function and giving as an input to another function. Okay? So we have seen like this is the code structure. Okay, there will be a client function that will call this orchestrator function, and this orchestrator function will execute all the activity functions over here and gives the result back. Okay, that's all. So this is how the code looks like. We'll see a simple demo also in this. So I just wanted you guys to know like how it actually runs. Okay, how it actually gets executed, how it actually gets the value from the history table and gives the result. Okay, I just wanted to give a brief intro about the code, that how it runs at the back end. Okay, so initially what it will happen is like there will be a client function, as I said before. There will be a client function. For example, let us assume that it has a startup function. Okay, so there will be a startup function. So that is the one that will call the orchestrator function. So as soon as the orchestrator function is called, we'll first execute the outputs is equal to new list of string, right? So now the outputs will have the list of string value. Next, we are going to call the call activity async say hello method, passing the parameter as world. Okay, let's assume this say hello function as an hello keyword already, and just we are going to append this world to it. Okay, so now as soon as it sees the activity call activity async method, it doesn't go and call the activity function directly. What it will do is like it goes and checks the execution history table. I told you like this durable functions will have a storage account associated with it, right? So that will have this history table also, this history table. So as soon as the execution gets started, it doesn't go and call the activity function directly. It goes and checks the history table first. Then if the history table returns null or false back to the orchestrator function, then only it will call the activity function. When there is no data or the result in the history table, then only this orchestrator function will call the activity function. So this activity function will get executed here. This activity function will get executed and gives the result as hello world. Okay, so this hello world will be saved it in history table. So once this is done, we will not go to the next statement, return output statement. It again starts from the first durable function. So now we are seeing the call activity async method again. So what this time it will do is like it goes and checks the execution history table, and this returns the hello world from the table itself, right? The task has been completed already and it is being saved in the history table as well. Okay, so it gets the result and gives back to the orchestrator function. This time we are not calling the activity functions because it is already been executed and the state is maintained. We have maintained the state as well as the result. So this history table itself will give the result back to the orchestrator function. So then we'll go to the return statement. That's all. We are returning hello world as an output. Okay, so this is how the durable functions work. So every time it will start from the first. As soon as it sees the call activity function, it goes and checks the execution history table, and if it is not there in the table, then it will call the activity function. And once the activity function is done, then it will not go to the next statement. It will start from the first and then checks the history table and gets the result. So that is how the durable functions work, we'll have these commands in it. So if you run a durable function, you could able to see the see all the commands over there. Orchestrated started, the execution gets started, task scheduled, the function name, comma, the parameter. So these are all the commands that will be saved in your HT table. So now we'll see about the pattern. So we have seen Azure functions, durable functions, and why do we need to go for durable functions? And we have seen the code as well, and we have seen the working of durable functions code. Okay. Now we'll see what how the patterns are in durable functions. The first one is function chaining. Chaining is nothing but we are doing it like in a chaining process, next to next, right? So kind of this function chaining is like a chain. There will be a chain of functions um, where the output of one function will be given as an input to another function. So for example, the orchestrate, let us assume that there is an orchestrator function here. That function actually calls the F1, then gets the result, and then calls the F2, then gets the result. This orchestrator function again calls the F3, gets the result in an orchestrator function, and get calls the F4, where the F1 function's output is given as an input to F2. F2's output is given as an input to an F3. So the code that I have shown you before is like a chaining process where the function one as an input called null, and we have saved that this one. Yeah, this one. So here, if you see, the F1 is a function that has a null parameter, null input, and we are executing this F1 function and getting the result in X, and then we are passing the X into the next function F2 and getting the result in Y, and then passing the Y to F3 function. The same way, that is what the function chaining is. Okay, so if you want, for example, this is a sequential process, right? So if you wanted to maintain error, if you wanted to handle any error in this function chaining or in this durable functions itself, you can use try catch statements, and you can execute this. Okay, you can handle errors as well. So next is fan out, fan in. So it is like the functions gets executed in a parallel way as it is given it over here. So for example, there is an F1 function. That result is given to an orchestrator function. This function will make the F2 functions run parallelly. Okay, so there are three functions that is running parallelly, and it is like fan out, right? Then we are making all the three functions go into a single function called F3 function. So we are fanning in. Okay, so what this will do is like this particular pattern, fan out and fan in pattern, will help us to execute the task in a parallel way. Okay, and now, so for example, we have three tasks that needs to be run in a parallel or in a concurrent manner. What this will do is like this orchestrator function will wait until all the three functions gets executed. For example, one may take a little time, the other one may take a little longer time, for example 2 minutes, 3 minutes, and 4 minutes. What this orchestration function will do is like it will wait for all the three functions to get executed and then gets the result. If the function needs to do some kind of aggregation, that it can do, and the result of the aggregated result can be sent to F3 as well. For example, let us assume like we are sending the marks of the student. Okay, we are getting the marks in each and every function. For example, the max mark, science mark, and some other subject. Okay, so what this will do is like it gets the mark and gives the result. Okay, in this we cannot give all the marks to the F3, right? We need to do some kind of aggregation. So what we'll do is like normal aggregation is like normal. We sum up all the marks and we'll send it, right? So we'll add up all the three functions values and gives the total to the F3 function. For maybe this F3 function can even get the rank for that particular class. Okay, so this is how it works. If you wanted to do any kind of aggregation, like if you wanted to sum up, you can sum up. If you wanted to get the average of all the three values, you can do that. So whatever you wanted to aggregate in that particular thing, you can get the maximum of the three, you can get the minimum of three, some aggregation function. Okay, some kind of aggregation that you want to do, you can do it over there and get the result in F3. So this is how it works. Okay, fan out is we are making it run parallel. Fanning in is like we are aggregating all the parallel functions and making it as one. The next is async HTTP API. So async HTTP API is like let's assume that there is a start function. Okay, this function is going to call the do work function. Okay, so we are just starting the function and making the do work function now. Okay, we'll assume that this do work function is a long running process. Okay, it is like a long running operation that might take a very long time. Okay, but we can't wait till the application gets finished, right? We can't wait. As a human, we know, like, we can't wait for so long time. So what we'll do is like we'll just navigate or make the client navigate to the get status HTTP endpoint. Let's assume this start as an endpoint. Okay, this is an endpoint. Okay, HTTP endpoint maybe. Okay, so this is going to call the activity function do work. Now what we'll do is like the client will only give this start HTTP endpoint, right? So we will redirect the client to get status endpoint, and this get status function will do is like we'll go and continuously poll whether the operation is going to get finished or not. So we'll just check with this get status endpoint. We are just going to get the status of that particular do work function. Okay, um, so this asynchronous HTTP API is like we are just addressing the problem of a long running operation. We can't wait for 10 or 20 minutes, right? So instead of doing that, we'll just go and poll and we'll come to know like how much time it will take, or it is going to be get finished or not. So those details, those status will be taken by the get status function. Okay, so this is the third pattern. The next is the monitoring pattern. So monitoring pattern is nothing but the recurring process. For example, what we'll do is like if you wanted, we have, okay, let's take an example of a customer. So maybe a company will have more than 100 customers. What they'll do is like whether the customer is active or not, we'll go and check, right? We as a developers, we need to know like how many people are actually using our software, right? So we'll go and check this the details of each and every customer. It is very difficult, right? We have to go and get into each and every customer's DB and get to know like whether they are active or not. So that is very difficult. What we'll do is like we can write Azure function associated with the data factory. Like we can give the list of customer details and get the result like whether they are active or not. We can get the result through a data factory, and then we can get the data, right? So what we will do is like we need to go and check every morning like whether the customer is active or not. Okay, so this is a recurring process. It is like continuously we need to go and check. So what we will do is like we will set a condition. Condition is like when the time is 9 o'clock, you just trigger this process. You just trigger this particular monitoring process or something like that. Okay, so in this it is like continuously polling until these specific conditions are met. So for example, you can take a normal while loop. Okay, normal, for example, we are passing I is equal to 1 and it runs till 10, right? So until the conditions are met, we are going to run the function. The same way this monitoring function will get run until the specific conditions are met. For example, we can even take, for example, we can give the percentage to the customer. Okay, 75 percentage the customers are using our softwares. The another customer is using our software for 25 percentage. So until all the customers gets 100 percentage, we are going to monitor the status. So this is how you can actually create durable functions and make the process. Okay, this is the fourth function. It is kind of a recurring process that we do every day. Okay, you can you can do this until the conditions are met. It can be any condition. Okay, the next is human interaction. Human interaction is nothing but there is a interaction of a human in between the process. For example, let's assume the customer details, very important customer details needs to be sent to a needs to be sent to a customer. Okay, the customer itself is asking us some data from our softwares. Okay, so that needs to be get approved from our higher authorities, and then only it can be sent to a customer, right? We need to verify whether the details that we are sending is correct. So what we'll do is like there will be a function called request approval. This request approval will call the person. For example, we can mail the higher authority, or anything that you wanted to do can be done in this request approval. So we have to wait until the person comes and approves it. Okay, once it is approved, then we'll call the process approval mechanism. If the person is not available for that particular time, then the timeout will happen. Once the timeout is done, we can call the escalate function, where this escalate function can have even more higher authorities contacts, and we can send this particular request approval to that particular person. The higher authority is higher authority. Okay, so it is like the upper level. Okay, so that is how this human interaction actually works. You can do this in your system. Okay, so it is like you can escalate whatever you want. You can even escalate that this person isn't replied, or whatever it can be. So this process actually gets the interaction of a human in between. So that's all. So this is these are all the patterns available in Azure Durable Functions. The first one is function chaining. The second one is fan out fan in. The third one is asynchronous HTTP API. Fourth one is monitor. Fifth one is human interaction. There is one more, I think, that is called aggregation. I haven't added that in this. The next thing is function types. There are so many function types, as I said before. I haven't added entity function over here. So the first one is the client function. So this client function is the one that actually starts the whole process. Okay, so client function will call the orchestrator function. Orchestrator functions code will contain the activity functions call method, and this orchestrator function is the one that is going to coordinate all the activity functions, and this will maintain the state as well. This orchestrator function will maintain the state as well. And then the activity function, this is the place where the actual function gets executed. So activity function. So that's all. We'll see a demo also. So I just wanted to show the complete structure, like how the code gets executed. So I'll start a new project. So if you have any doubts, you can post it in the comment section so that I can answer. Maybe if I'm not aware, also uh, I can go and check and then let you know. So when you create a new project, you need to create your Azure functions as your template. So once you have given the Azure functions as your template, maybe a demo, I'll change the location as well. Sorry. So in this, I'll just create a new section. Okay, I'm just going to create a new project with the template Azure Functions. So in this Azure Functions version 3 .NET Core, and I'm just going to create an empty Azure function with no triggers. Okay. So I am just going to store whatever value in my storage emulator. I'm not going to attach any other storage account to it. So I'm just going to create it. So this is just an Azure functions. Okay, I'm just now creating a normal Azure function that will not have any kind of triggers into it. Okay, now what I will do is like I'll go and add a new Azure function. So I'm just going to create a new Azure function into it. Inside, I'm just going to call this as an orchestrator function. Okay, can be whatever. Okay, so as soon as you create an Azure function, it will ask for a trigger type. Okay, so now I'm going to give a durable function orchestration as my trigger type. Okay, because like in the code I've shown you, like durable orchestration should be there if that is an orchestrator function. So I'm just going to create a durable orchestrator function. This will take little time. Yeah. So now I'll just explain the code, like how it actually works. I've told you, right, there will be a client function. So this is the client function. So okay, durable client is the word that we are using it here. So this is a client function. This is the one that is going to call the orchestrator function. So any this is the one that is going to get started first, and then we are just calling the orchestrator function is nothing but this function. So this will have the orchestration in the orchestration trigger in the uh, function. Okay, so this will have the call activity async method. Okay, this is a default Azure Durable Functions code. Okay, this is going to call the activity functions. In this, we have a normal say hello method. We are just going to pass the string name. It is an activity trigger. We could able to see it in the argument itself. Okay, so we are just going to get the result as hello Tokyo, hello Seattle, hello London as an output here. Okay, I'm just going to run this. So I've told you, like, this is a normal HTTP trigger endpoint. Okay, we haven't used any other thing. It is an orchestration trigger, but we'll get the HTTP endpoint here. Okay, in the durable functions, it is an HTTP endpoint. By default, it will be an HTTP endpoint. So this will gets executed. Might take little time. I don't know why this is taking so much long time. Maybe I can close this and open it again. Here I'm just running the durable functions code. That's all. Maybe I can show you one more if it if this is not working then. In the meantime, if you have any doubts, you can post it in the comment section. It is taking a bit longer time to execute. I don't know why. The function.exe is the one that will run the Azure function. So this will be in the Azure function tools. I don't know, this itself isn't actually started. I don't know why. So I'll just call the another one program that I have executed before. So I have a demo as well. I can show it maybe after this complete process. I'll show the real demo. I'm just showing like how to create durable functions, and then how we are going to publish it in the cloud as well. Okay. Maybe this is going to take a longer time. I don't know. My system is it's very slow. Maybe in the meantime, I can go and show you another one demo. Uh, this isn't. Yeah. No, this hasn't come. Yeah. So the same code, okay, the same normal demo function. So what this as is the same uh, hello Tokyo, the same result. Okay, I'm just going to run this. So when I run this, I'm going to get an HTTP endpoint. Oh, it is saying that the tool is very busy. I don't know why. This is taking a very long time. Okay, in meantime, I'll show you some other demo, like uh, the real pattern. I've used a workflow pattern, like function chaining pattern. How do we need to write a code for it? Okay, so what this is going to do is like, this is the orchestration function. This is going to call the conference book conference function, book flight function, and book hotel function. Okay, these are all the functions that is going to be called in a sequential manner. So for example, you need to book your conference, right? For example, uh, if there is any Azure conference, what you will do is like, you will first book the conference. Once the ticket confirmation, once the booking is confirmed for your conference, then only you will go and book your flight tickets. Once the flight ticket is done, then only you will confirm your hotel, right? You will go and book your hotel. So this is the process. Like, so what we are going to do here is like, we are going to first go and book the conference. Okay, this is just the return type of conference ticket, and I'm just going to get the conference details over here, with the conference detail passing as a parameter to the next book flight function, and then getting the result as flight and sending that to a next function. Here I'm just given the output as a normal statement. Okay, I haven't used anything bigger. I'm just going to show you like normal book conference that will have the activity trigger. Here I'm getting the event name um, from the conference that we are sending, that we are yeah, the event name we are passing it over here, right? Yeah, here I am saying it is monkeys Monday, like something. For example, we can change this to sinfo sinfo v underscore tech. Okay, that is the today's event, right? So we can send this as a parameter. So we are going to get the input in the event name, and I'm just telling welcoming you to register to the organized by something. We can say it like yes. So this is the one that I have used it before. So S Infotech may be organized by Vignesh. Okay. So this is how the log statement would be. Next, I'm just going to get the result, like normal result. I'm just making the values in a normal strings. Okay, I'm just going to give this result as an output. Then I'm just going to call the another function. Sorry, another function called book flight. The same way I have written the book flight as well. Okay, main two things you need to follow, you need to make sure is like that should have an activity trigger. The other one is the function name. The function name should be correct in as it is in the function chaining. Okay, so these two things should be correct. So in this also I've just created one class called flight ticket. In that I have all the properties like this, and I'm just returning it. Okay, I'm not doing anything else. I just wanted you guys to understand how the pattern works. Okay. Next is like say the same way I'm just returning the result and calling this one. So the function chaining process is like a sequential process where this will call the book conference method first with the parameter sinfo underscore tech, then the book flight function with the conference as input. Conference is over here. The first function's output is saved it in the variable called conference. So I'm just passing this conference as an input to the another function and getting the result in flight and passing the flight as an output to the as an input to the next function called book hotel. So I'm just going to make this functions run sequentially and get the result as hotel confirmation. So at the end, what we will get is like we will get the result as your booking has been done successfully in the hotel's name. Okay, so that's all. So this is how the function chaining works. Okay, I'll just check. Yeah, this has got triggered. Okay, as I told before, when there is a durable function, there will be an HTTP endpoint. So this is the HTTP endpoint. I've told you before there will be an HTTP localhost 7071 underscore slash API. This starter underscore HTTP start is the client function. This is the client function's function name. So we are going to call the client function only. Okay. So when I get this, sorry, when I get this, what I'll do is like maybe in some other. Okay, I'll just put it in another one now. This is running, right? Yeah, this will give me the durable functions ID, a status URL, like the state. This URL will give me the actual status, the output, how much time it got executed, it takes to execute. So those details will be in this status query. Okay, most of the other URIs we don't use it that much time. So this is going to give us the instance ID, the runtime status as completed. Yes, it got executed. We haven't sent any input, right? It is a null input. If you see, we are just passing a null input over here. Starter function, we are calling the starter function and we are passing null input. So no input. The output is hello Tokyo, hello Seattle, hello London. Okay, the created time and the updated time. So this is what the result is. So as I told you before, this the starter function will call the function orchestrator function named starter. So this orchestration trigger will execute each and every activity function and the output will be given it in a status URL. Once you go and check the status URL, you could able to see the output. Here it is. Hello Tokyo, hello Seattle and hello London. Okay. So this is how it works. If you have any doubts, you can post it. So that's all. This is how it works. So if you wanted to publish this particular function into your cloud, what you will do is like we are just going to publish. So I've told you, right, history table. I will show you like how the history table looks like. Just you can even see it in your Visual Studio as well. So but for I'll show it in my Azure Storage Explorer. So 5/8 is the time that I have run it. Yes, this is the one. Your booking has been done successfully. Function chaining mechanism. No, 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 no. The second one is the one that I have run. 13:21. I think the time in UK. Yeah, 4.5 hours before. So this is the one. So actually, I've called the method starter, function starter, and I've got the result as hello Tokyo, hello Seattle, and hello London. Okay, so if this is a status URL, right? So if you wanted to know the history itself, what you'll do is like you can go and check it over here. This is the one that I've run it before. Yes, starter allow are the activity functions that I have used it. Allow to, so if you go and see the result, you could able to see the result of all the things. Okay, so this will at last give the end result. So this history table will have all the details like the orchestration started. This is in a timestamp is in. Exactly correct. Okay. Yeah, now it is correct. So I'll just show you the execution started, orchestration started, task scheduled, orchestration completed. So this will have each and every result. For example, this task completed will this is the task completed. So this will have the result allo Tokyo. So if you see, so this is the task completed. The another task completed will have the next result. Allo Seattle. The another task completed will get the allo London statement. Okay, so this is how the history table will have the details, will have the records over here. So if you wanted to publish it, you can do it. Like you can create a new one as well if you wanted to as your function app. And if you wanted to create a new Azure functions, you can do it as well. But I have created it already, so I can use the same Azure function. If you wanted, you can create a new Azure functions as well. So this will have the name. I have told you like whenever you create a function app, you will get the storage account associated with it. So you will create the storage account as well. So once you do, you can publish it in your um, cloud. So that's all. This is how the publish will happen. So if you have any questions, you can post it, or you can if you have any doubts, you can maybe ping me through my Twitter handle, Niveta Lakshma too. I can post it in the YouTube comment section as well. So, any questions?
And if you have any question, please post here. Niveda, thank you so much, Niveda. I think we don't have any questions. So if you have any questions, definitely they will post here. So thank you
Okay.
so much for your valuable time. Thank you so much.
Thank you so much, Vignesh, for this opportunity. Thank you.
Yeah, welcome. Yeah, thank you so much. Okay.
Yeah.